Hello, everyone. Hope you're having a great week. So, today we'll be speaking with our great speakers. We have Zain Hassan and AG Chan from Weaviete, and they will be walking us through Weaviete technology for our AutoGPT Arena hackathon. That is a 3 weeks hackathon. So we know that the hackathon has kicked off on Friday, and all of you have been building. So this workshop is to help you with the technologies and all the coding that you need. So please ask all your questions in the chat. And in the meantime, we will have the great Weaviate team speaking us through and taking us through their coding and how their workshop with all the technologies and everything. So Zen, the stage is all yours.
Awesome. Thank you very much.
Thank you.
All right, folks. So what I've planned for here is about a 40-minute, 45-minute workshop, and then I'd like to uh, take some time to answer questions. The workshop is pretty much introductory. I want to show you how you can go from basics in Weaviate to more advanced things like multimodal search and how you can search over images with text. So I'll show a demo of that as well. Everything that I show is open source, so if you want access to the code afterwards, I'll link it later on. I'll also send out the slides later. Okay, so let's get started here. My name is Zan. I'm one of the developer advocates here at Weaviate. Um, and yeah, so let's go ahead and right. So in the Twitch channel, if you could in the chat just let me know what your background is. Do you know about vector databases? Have you used them? Do you use them for work? Do you use them for side projects, for hobbies? And on my other screen here, I'm just going to go ahead and open the Twitch chat. And I like to read some of the responses so that I can calibrate the workshop. A bit of ChatGPT knowledge through the API. Okay. Yeah, use Pinecone, Chroma, and Vice. Cool. Okay, cool. So this workshop is meant to be introductory in the sense that even if you haven't used a vector database before, I'll introduce it, and then I'll quickly bring you up to speed about how they work and how they can form the backbone of your next search engine. Um, they can do a lot more than just text search. Right? A lot of people use them for text search because large language models can understand text, but now that large language models can understand a lot more than text, with the recent release of the last GPT version, that's multimodal, um, I imagine we'll be seeing them used for a lot more than text with images and video modalities as well. All right, let's jump in here. Let's talk about what a vector database is. Everybody knows what a database is and probably used a database. A vector database is similar to this technology, except there's one thing that's fundamentally different about it. It can do the same thing that any of your other databases can do. It can catalog, store, retrieve information. You can perform CRUD operations. You can delete objects, update them. All of the general stuff you can do with a vector database. The only fundamental difference is that it filters mainly based on similarity. So if you have a concept that you're interested in, you could go to Google and you search up that concept, and it will bring you all of the web pages that are relevant to that concept. A vector database does the same thing, this sort of semantic or similarity search, but over your own data. So one way that I like to think about it is if you take all the files in your computer, all the videos, images, text files, audio files, and you search for a concept, like a family picnic at the beach or something like that, it'll bring forth every relevant file to that concept. It doesn't search over metadata, it searches over the concept of the data itself. So in order to do that, it has to understand that data. Um, let's go in and try to understand how this similarity search works. All of your documents and you're storing them in the database. Technically, classically what you would do is perform keyword search, right? So you would look for a keyword like Python, and because this doesn't exist, nothing comes up. And this is the critical problem with keyword search. It's essentially just string matching. You're pattern matching, and it doesn't understand what you're trying to search for. So it can't differentiate between the programming language and the poisonous snake. What machine learning based semantic search or similarity search does is that it tries to understand the concept that you're searching for. So here we're searching for the programming language, and it matches with that, even if the string that you're searching for is not present in the sentence. And how we do this is by using machine learning. So we embed all of these concepts into a uh, into a vector space, some numbers that we can quantify, so that we can measure how different the number for this is compared to the number for all of our documents. So this is known as machine learning based semantic search, similarity search. There's a lot of words for it. Some people call it neural search because a lot of the machine learning algorithms that are used to generate representations of this data are neural networks. Um, this is mainly what I want to get across to you in this workshop. So if you're writing a query for a SQL database, it could look something like this, right? So I select column names from a particular table where I do some sort of pattern matching here. Right? So if I'm interested in major European cities, let's say I do some sort of regular expression here that extracts out major European city. But then I'm also going to have to account for all the different flavors of how a major European city can be written down or represented. So an important European city would also match, prominent European city would also match. The issue here is that I'm trying to search for a concept, but I only have tools that allow me to do string matching. In a vector database, this would look like this, where you can query with natural language. If you're interested in a major European city, you could just describe it. The more descriptive you are, the better the vector database is able to locate your concept and then retrieve and return more similar concepts to you. And so this is what a vector database enables. It allows you to search over your data intuitively using natural language. So let me show you this in action. Um, I'm not a fan of slides, so let me just show you code here. So what you can do is, you can get access to this code over here, by the way. So let me put this in the... oh, I can't. I'm going to have to log into Twitch. I'll do that later. I'll send this out later. Um, but what I'll do for now is just show you what this code looks like. Right, so here. So what I've done here is just set this up. I've went to Weaviete Cloud Services, and I've already created a cluster for us to connect to. This is probably the easiest, lowest barrier way to get Weaviete up and running. You can just create a sandbox cluster here. And then what you'll see here is the URL that you'll need to connect to it. So you'll copy that, and then you'll also see the API key that you'll need to connect to this instance. This is just a demo instance that I've loaded up with 100,000 objects that I'm going to show. Okay, so once you've got this up and running and you've grabbed the information here, you can go in and, oh, thanks AJ, I know that he's posted that there. Okay, cool. So now what we're going to do is hook into that cluster. So I've pasted the URL here, and then that API key I've grabbed and pasted here as well. For this particular example, we're also going to be using OpenAI and Cohere for our embedding purposes and generation purposes. So I've got to include their API keys here as well, right? So when you're setting this up, make sure to have these set up as well. So this is just a quick check to see that we're connected to the backend. The next thing that we're going to do is create. Well, I'll skip over the schema. I'll come back to the schema. So this one, I'll skip over. Let me just show you the data. Right. So I showed you that there's 100,000 objects in this database. So this is what the 100,000 objects look like. Second. So they're essentially Wikipedia articles that I've chunked into 100,000 text chunks here. And so one Wikipedia article can be chunked into multiple text passages, and we've embedded them over here. So this is the vector representation for these text chunks. And so now, and we'll talk about this later, each vector representation is 768 dimensional. This has to do with the machine learning model that's used to capture the meaning behind the data. I'll talk about that more in a second as well. I then uploaded this data, all of 100,000 objects, which is what you see here. Right? So the 100,000 object count that you see here came from here where I batched and uploaded the data. And then, so what I wanted to get to here was searching over the data. So how you search over your database now is you can either do classic keyword search. So this is pure string matching. Right? I'm looking for titles that have or like this value string, so that have the string dog in them. So if I run this, I'll bring up Wikipedia articles that have this string in them. Right? You can do the same thing for articles, title search. You can do the same thing for text search. If you're looking for the keyword dog in text, you would just go in and modify the path to be the text property. So this is basic. If you try to do something similar here, where if I search for a regular expression that has fastest animals somewhere in between, sandwiched in between other strings, you don't get anything here. And the reason why is because if I look at the result, the query result, it returned nothing because there is no article that has fastest animals in the title. And so here I'm just trying to search for a concept, but keyword search isn't able to retrieve it. Right? And this is the main problem with classical search, where you're kind of trying to search for meaning through string matching. What you should rather do is what's known as vector search or semantic search that I was talking about earlier. Right? So here I've created a function that takes in a concept here, a query, and this query can be anything, like fast animals that live in the sea, fastest animals, and we can search over our data using this natural language. Here I've included a bunch of other things. You'll see in a second why. So this will return to me um, text for the Wikipedia article, the title, the URL, the views, and then also this thing known as distance. We'll talk about what this distance is in a second. And then I'm just going to format the response so that you can see it nicely. So I'm going to run these helper functions, and then I can go ahead and search for fastest animals. If you do this, you get relevant results back. The string itself doesn't need to be in the actual return return text. Right? And you can search for anything here. Right? Um, easy to cook meals. Search this. You get interesting concepts back. So if you get back a title that seems like it doesn't make sense, you can read the text to understand why it might or might not be relevant here. Um, okay. So we can also do the vacation in California to get back relevant results. You can also, so you can even rate entire sentences, right? So the more descriptive you are here, um, the better, because you're able to locate the input query better in this concept of vector space. Okay. The other cool thing here is that, okay, so let me go back here and let me talk a little bit about how this works. So how can you perform this natural language querying over your own data? The main idea is this concept of a vector. The reason why it's called a vector database, because you take all of your data representations, whether they're text representations, images, video, you pass them through a machine learning model. And the point of the machine learning model is to translate your data from uh, formats that we understand, human understandable formats, to machine understandable formats, right? So these are the vectors that I was showing you earlier that are 768 dimensional for that given model that I was choosing to use. Right? It's almost like taking your data and passing it through a Dewey Decimal classification system where if you want to locate a particular book in a library, based on the topic of the book, you can find out where it's located in the library, and then you can go there and try to do a more fine-grained search. So each vector locates a concept for that data point, and then it plots it out on a vector space, which could look like this. Here, this is just 3 dimensions, but usually vector space that we're using for production level search is very high dimensional. The one that I just showed you is 768 dimensional. Usually, the more information that you want to pack and you want these numbers to represent, the more dimensions you're going to need. You can also here represent images as well as text in the same vector space. Um, so in Weaviate, we have a couple of modules that allow you to embed all of these data points into the same vector space. And then what this enables is that you can perform search with words and you can get back images, or you can perform search with images and get back other images. I'll show you that in a second as well. So I think that the potential for that is pretty much unlimited, especially with new multimodal models coming out. I think people can have a lot of fun with that. So now the idea is that every single data point here, you can think of it as every file on your computer, exists as one vector, and vectors that are closer together are similar in concept. So the vector for cat and the image of the cat itself is closer together, whereas the vector for the word cat is farther away from the word apple or banana. So a vector database is essentially like taking a data point, locating it somewhere in a library so that it's next to or near similar concepts. And then a vector search engine is essentially a superhuman librarian that if you tell them what you're interested in, they can go and retrieve objects and they know exactly where to go and look. Okay, so I wanted to dive a little bit deeper into how this vector search is actually carried out so that you have a deeper understanding of what's going on when you hit enter. Right? When I was searching for vacation spots in California or programming language for data scientists, what is actually happening? If we take this vector space that we've now understood and we have in our vector database, when you ask a question or when you query something, all it does is pass this query, so vacation spots in California or um, programming language for data scientists, and it generates a vector for that query, right? So this red dot over here, you could think of it as the query vector, and then all it needs to do now is this proximity search. So if you can identify which objects in my database are in close proximity in terms of vector distance to my red dot, then I can retrieve the 3 most or 10 most or 5 most relevant objects to you and return them. The thing that you have to be careful with here is if you search for a concept that your embedding space doesn't know about, you'll still get back the k most relevant concepts. So then it's up to you to determine relevance. Right? Um, there's other techniques that you can work with to gauge relevance here, but really one of the things that you have to be careful about is if you search for a concept and your vector space doesn't recognize that concept, it'll give you the next closest thing, which might or might not be close. Right? So you have to be careful when you're using this. Um, in reality, when I say proximity search, we're not actually going out and comparing every single object here, and we're not comparing the distance between the red data point and every other green data point. We're doing this layered hierarchical approach so that we don't have to compute n distances. We only have to compute a log number of distances between this query and the number of objects that we've embedded already. Um, you don't need to understand any of this to use a vector database, but I think it's helpful to understand why a vector database enables you to search over billions of objects in real time. Okay, so now with that understanding, what I want to show you is what I like to think of as the superpower of vector databases. Right? Because the machine learning model embeds data into numerical representation, the machine learning model can be trained to understand multiple types of data. Right? It can be trained to understand multilingual data, which this model is. Right. So, for example, if you're for the hackathon particularly, if you're interested in making semantic search over multiple languages, you can use this model, and then you can search for um, concepts across multiple languages, right? So because this model understands 100 plus languages, you can query in Hindi, in Farsi, Chinese, whatever you'd like, and you'll still get back relevant results. So here, this is Hindi for good movies, and I don't speak Hindi, but I can tell that the results are relevant here. This is vacation spots in Farsi, so you get back relevant results here as well. And then the other thing that you see here is that you get a distance metric of how close or how far away the object that you're getting back is from the query vector. Right? And this is great action movies in Chinese as well. So the reason why I demonstrate this is because whatever your machine learning model understands, whatever machine learning model that you've hooked onto the vector database, um, you will be able to search in that modality. If your machine learning model understands Chinese, you'll be able to pass in Chinese queries and it'll give you relevant results. The reason why you only get back English results here is because the only thing that I've put into my vector database is English. Right? So here it's performing cross-language search, which is pretty cool. Okay. So if we zoom out, what is the big picture here? A vector database revolves around an encoder or a machine learning model, and Weaviate is integrated with multiple ML model providers from OpenAI, Cohere. If your model is on Hugging Face, you can simply plug and play. You can even bring your own model. So if you vectorize your own data previously, you have the vector representation for the data. You can pass it in when you're uploading data. So all of your data essentially goes through this machine learning model, and the vectors that are generated are stored in the vector database. So another reason why people think of vector databases as vector stores, because they store the vectors. Um, and then a user comes along with a question or a query that they want to use to retrieve relevant concepts from your data. This query goes through the exact same pathway, and it now exists as, you can think of it as a red dot, and then you do proximity search, and what you return is the list of candidates of objects that are close to this query. And as simple as that's as simple as what's happening. There's a lot of engineering nuance that's going on underneath the hood, but for the purposes of this hackathon, um, it's enough to understand this. The second to last thing that I want to show before I show you some cool demos is thinking about why you would use a vector database. Right? One of the users, one of the people in the chat mentioned that they'd use FICE. Um, the difference between FICE, which is a vector library, versus a vector database like Weaviate, is that a vector database supports CRUD operations. It allows you to insert objects on the go, right? So if you have data that's changing over time, if you have 10 new data points today and 20 new data points tomorrow, you need the ability to be able to search over them in real time as they come in. So one of the main reasons is as you're scaling up your data, you can insert it and the database scales up with you. Whereas a vector library needs to be re-indexed and recreated every time you have new data points. Um, so CRUD operations and real-time updating is one of the main applications of why you would use a vector database. The second application is scale. If you're performing search over thousands of vectors, tens of thousands of vectors, you can get away with even using something like scikit-learn or any other data science library, and or even using NumPy actually. But when you get up into the millions of data objects, tens of millions, hundreds of millions, billions of objects, now this search where you're doing nearest neighbors retrieval, um, uh, it doesn't scale well because it's essentially calculating the distance between every query vector and every other object that you have in your database. So to get it to scale up to the millions or billions of data objects, you need this approximate nearest neighbors that we talked about, which is the bread and butter of every vector database out there. And so when you're getting up there in scale, which with the abundance of data that we have, it's very easy to get up into the tens of millions, right? Um, so when you're in the tens of millions of data objects, you won't be able to use NumPy. You have to use a vector database. Um, And especially if your application requires vector search at that scale, where you're filtering over tens of millions, hundreds of millions of objects, you'll need a, a vector database that's built with vectors in mind. If you're uh, if you're searching over hundreds of thousands, then you can use an integrated vector database. Um, but if you're searching over millions or tens of millions of objects, then you need a dedicated vector database. So if you're trying to decide between a dedicated vector database versus an integrated vector database to another core technology versus something like NumPy or data science, the question you have to ask is how much scale are you wanting to search over? That should actually say billion. So we've verified this. There's customers that are using this at the billions of scales, at the billion object scale as well. Okay, so now I wanted to show you what you can do with Weaviate. So here, if you go into Weaviate, you can go into the docs. Um, the cool thing about this vector database is that we've already integrated a lot of the functionality for you. I want to show you a couple of these functionalities. So for example, let's say we go into vectorizers and we've got a bunch of multi-to-vec uh, modules here. Multi-to-vec clip is the very popular multimodal model from OpenAI, and multi-to-vec bind is the one from Meta that was recently released just this year. Um, so I created a demo using multi-to-vec bind. Multi-to-vec bind is a machine learning model that understands images, text, video, audio, um, and a couple other modalities. Right? But those are the most interesting ones. So I built this search engine that can search over. So I've put audio, video, images into the vector database, and I can search over those modalities using all of the other modalities. Right? If you have a multimodal um, machine learning model, then you can hook it onto a vector database. And with Weaviate, we've already integrated it. And then you can use this ML model to now perform cross-modal search. And what I mean by cross-modal search is I can search with text, and I can get back images, I can get back video, I can get back audio as well here. So this is also open source. You can, if you want to look into this, you can view it here. So this is the multi-to-vec bind app. And the cool thing here is that a lot of the times when I show people this demo, they think that you're doing some sort of metadata matching where you look for city car in the metadata of the image, or maybe you're matching with the name of the image or something like this. But in fact, what's happening is that the actual data, the video here, is being turned into a vector, and that vector is close to the vector for this string. The image here is being turned into a vector, and the vector for this image is close to the query vector, which is a text here. Right? The actual audio is being the um, the signal intensity is being digitized, and that vector is close to this text vector. You can even do image search here, right? So for example, if I go in and let's say I go in here and we go into where's this projects. Let's go here. Oh, 1 second. Let me just locate some images here. Yeah, so let's do this. If I pass this image in and I ask for relevant images, I'm performing image to image search. And all of this routing is handled behind the scenes. So if you take the power of this model, and if you take the scalability of a vector database, in terms of a hackathon, I think you can get a lot done. Right? The audio search is probably my favorite. Right? So let's say you have, I don't know if you can hear this, um, but this is the audio of a lion roaring. If I put this into the vector database, I get back relevant concepts. Right? So here you're really doing cross-modal search um, between modalities. So if I only had audio files in my vector database, you could actually build a app like Shazam, um, where you can take a snippet of a song and then you could retrieve the entire song um, based on semantic search. Okay, so that's one demo, and it's very easy to build this with Weaviate. So if this gives you some ideas for the hackathon, that's great. The next thing that I want to show you is retrieval augmented generation, right? This idea of generative search, which a lot of people are interested in. Um, so generative search or retrieval augmented generation is quite simple actually. What it does is you do the same workflow of prompting a large language model, except now you have some relevant context that you give it. And so, for example, what you do is here you can ask a vector database, or you can ask a user to go in and select relevant documents, and then they filter from your list of documents. Let's say these are all the PDFs on your file, and you say I have a prompt that has to do with um, I don't know, how to change the oil in my car. This user is going to go in and extract out the manual for your car, and now you have relevant context that has the answer or that provides relevant information to answer this prompt. So then you sandwich that relevant context into the prompt and you pass it to the large language model to generate off of. And this gives you customized responses rooted in your own data. Notice how this data doesn't need to be in the training set of your large language model. It can be completely separate. So you can get your large language model to reason over data that it hasn't seen before. Um, so the only difference now is that if you want to do this over billions of data objects uh, in real time, you want to essentially plug in a vector database here and use it to filter relevant concepts. So you can say, out of the 100 million objects that I have here, what are the three most relevant objects to this particular prompt? And then you can sandwich those three objects into the prompt and pass it into the large language model. And this is the most basic form of retrieval augmented generation. It's called retrieval augmented generation because you're augmenting generation using retrieval of of the vector database, or with the vector database. So essentially, how this changes your old workflow is everything is the same. You have your database goes through the machine learning model, the query goes to the ML model, it lives in Weaviate. Now, instead of retrieving a set of candidates, you just send it to a large language model to generate using. So let me show you what that looks like in action. So here, I'll come back to hybrid search. If you're interested in uh, practically using a vector database, hybrid search is also great. I'll talk about that in a second. Okay, so here, let's say I'm interested in famous basketball players in the NBA, and I just do a semantic search, right? So I get back three articles, Wikipedia articles for basketball players in the NBA. Now what I want to do is, instead of just seeing the results, I want these results to be sent off to a large language model. And here the large language model is GPT 3.5. You can modify that underneath the hood. What I can do is write my prompt that I would send to GPT, but I can now refer to the properties from the returned objects from Weaviate, right? So I can refer to the titles, and this title will get replaced by the individual titles one by one. Right? And then here I can also pass it information by passing it the text property, which is just this chunk of text. Right? So I can get it to write me interview questions for Will Chamberlain, and then I tell it some piece of information about Will Chamberlain, right? Magic Johnson and Shaquille O'Neal. So when I run this one takes a longer amount of time because this takes into account both the retrieval time as well as calling the OpenAI API to get back the result. Right? And then if I just print out the result, you'll see that here, this is the interview that was generated by the large language model. And the context we gave it was Magic Johnson and some information about Magic Johnson. Same thing for Will Chamberlain. The information we gave it, this was retrieved, and this generation was augmented using this retrieved text. And then same thing for Shaq. And so here I can just go in and extract one out. So this is the interview with Magic Johnson. You can even get it to mimic Magic Johnson and then answer these questions as well, which is pretty interesting. So what I've done here is simply go in. If you want to do this with Weaviate, it's one line of code where you can query the client and tell it what properties to retrieve back. You need to give it the concept that you're interested in retrieving, so the famous basketball players in the NBA, which just returns this. And then instead of showing you the returned objects, you want to call a with generate call. And here the single prompt means that for every single object that's returned, I want to generate one prompt. So you generate one prompt per object, which is why I get one interview per basketball player here. You can also, depending on how you want to prompt this thing, you can also do a group task. Right? So, for example, I can go in and say I want to search for famous basketball players in the NBA, and I want to retrieve 15 results back. And then I have this grouped query where I want one query to be answered using all 15 results. Right? So here I say which of these players, and then I give it information about 15 different players, is the most accomplished one. So now it's going to read over all 15 results, and then it's going to answer this query by picking out who the best basketball player is. So this one retrieves 15 objects, generates only one object. The previous one retrieved 3 objects and generated 3 objects. So here, these are the 15 relevant pieces of information that I gave it. And notice that I didn't just give it the titles, but I also gave it the text or the relevant context for this. And this is the generated response, right? So it thinks that Michael Jordan is the best out of all of these players, some of which are relevant, some of which are not relevant, right? So James Naismith is not a basketball player. He invented basketball. And then you can do this, you can use this for very interesting applications, right? If you have a YouTube video and you can transcribe it, you can get it to answer over the YouTube video, you can get it to summarize over the YouTube video. Um, Essentially, you have the reasoning power of a large language model, and you can control it using retrieved context over your own data. Your own data can be YouTube videos, your own PDF documents, anything. And so here, this one is particularly interesting. So here, I get it to tell me a story about where these 5 retrieved basketball players fight each other, and then somebody comes out on top. Right? And I'll just end with this one. So the whole prompt here is that, yeah, tell me a story where these people fight each other, and the titles that I've passed in here are these 5 titles. It's some of the greatest battling it out. And then here, this is always interesting because the temperature is high for this model. It the generation changes every time. I like to see who wins. Oh, it didn't even dribbled. I can't even tell who won this time. It's just saying that everybody won. Oh, that's horrible. It needs to pick one. But yeah, that's it, folks. Um, I think this combined with the multimodal components in Weaviate, because everything is already integrated, you can simply put your data in and then type in one line of code to do retrieval augmented generation or multimodal search. Um, so I think for hackathons, it's pretty awesome. The additional factor here is that in order to take this from what I'm showing you here in my toy notebook to production level, it's not that different. Right? So the scalability, both in terms of searching over billions of objects and then scalability of taking code like this and putting it into production, that's an additional property that's really cool. All right, awesome. So I'll end there. If you guys have any questions, let me know. I'll also be around. Our team will be around as well on Discord. So as you're using Weaviate, let me know. Let us know if you have any questions. Like I mentioned, all of these tutorials, the code is all open source. So if you want to use this, feel free to build on top of it. Okay. Awesome. I'm looking at the Twitch chat here. I'm not seeing anything. Um, I don't think there is a Discord chat this time, correct, folks? So what I'll end with here is just some relevant links. If you're interested, you can connect with us on Slack. We have a forum as well. If you have any questions for me, you can also connect with me. Um, for this hackathon, I think Discord will probably be your go-to. Um, if you believe at Weaviate Mentors, all of us will get a ping, and then whoever is available will reach out to you. Okay.
Okay, Zen. Hello. So
Hello.
thank you, Zain, so much for this amazing session. Really great talk. And as Zain said, so in AutoGPT Arena Hackathon, it will be held in their AutoGPT server, but you're always welcome to join our server, LabLab AI. And in the meantime, please ask all your questions in the Twitch, and we'll be here to assist you for the next few minutes. And following up, we will have our speaker from Weaviate too, I believe. Let me check. Yeah, sorry, BabyAGI talk. So we will have our speaker coming in soon. And in the meantime, please, guys, feel free to ask your questions. Me and Zain will be answering them. There will be Discord and happy to. There's the general Discord hackathon channel, isn't there? Yes. So we have two Discord hackathons, two Discord channels, servers. There's the AutoGPT server and there's the LabLab. But the AutoGPT Arena hackathon, it's held in the AutoGPT server. So all the looking for a team, all the people who are looking for help or general like questions, mentoring, it will all be in their AutoGPT server. In the LabLab AI server, we'll be supporting not so much limited support, but we have a lot of other hackathons going on that we can be able to support you in. Feel free to ask your question, guys. Okay, everyone. So this was our first great session with Weaviate and their team, Zain Hassan, AJ Chan, and Philip. Thank you guys always for mentoring a great mentor session. And for now, we will take just a 5 to 10 minutes break maximum, and then we'll come up with Baby AGI, and they will be working with us in a workshop session. So see you all in 10 minutes and have coffee, water, hydrate, and see you soon.
Okay, folks. Take care. Bye.
Hello, everyone, and we are back with the amazing Baby AGI team. So we have with us in this session Nakajimi. My apologies if I spelled your name wrong. So Yohi today will be talking with us about Baby AGI and the technologies. But before we start, how are you, Yohi, today, and how's
I'm
everything?
doing good. Thanks for having me. I know I was pretty busy, so I know it's pretty early in the morning, but excited to be here.
We're really glad to have you here too. So, Yuhi will take you guys over Baby AGI technology and have a cool session with him. Please ask all your questions in the chat. Feel free to ask him because this is a great opportunity to get the knowledge, to get the information, and to get everything you would like. So, put your questions in the chat and we'll be here to support you. Yuhi, the stage is yours now.
Thank you.
Thank
Hey
you.
guys, as mentioned, if you have any questions, comments, or things you'd specifically like to hear me talk about, please just drop it in the Twitch chat. I have it open. Um, I've talked a lot about Baby AGI. I can talk about the concept itself, the code, how it works. But also, I thought it would be good to talk a little bit about what I'm seeing in the autonomous agent market, both as as an investor as I look at these companies and the directions and opportunities I see it going, which I thought might be helpful to better understand. Oh, I need to better understand kind of the opportunities on what to build. Let me quickly get this. Give me
Yes,
one quick moment on the background noise.
it's okay.
Apologies. Let me mute myself for a second. Hold on. I'll be right back, friends.
And I'll be
Sorry
back.
about that. I'll be back in two minutes.
Okay, I'm here. Don't worry. And yeah, hello everyone. So I'm back. So he will just take care of his child. We love a great father. So yeah, we really have a great team over here. So people, please, baby AGI session. That's a good one. But yeah, so ask all your questions, and as you can see, we're having great fun.
And I'm back. That was my secret advanced baby AGI project that I haven't announced yet. So,
Yeah, we just said that this is a great baby AGI session. So
yeah, I got babies a day and night. It's fun.
so you're not only a great coder, but you're also a great father. So thank you.
Thank you. So yeah, all right. So I'll jump in. I'm gonna start with. I mean, for people who haven't heard it, I'll share this quick story of Baby AGI. Some of the things I've added to it since announcing it, and then as I said, I'll talk about kind of autonomous agent space and some opportunities. So please feel free to jump in and ask questions or things that if you want me to cover. The history of Baby AGI. This was back in. I guess as a quick introduction. Again, I'm Yohei. I'm a VC by day. I run Untapped Capital. It's a small pre-seed generalist venture fund. One thing that makes me, I think, unique as a VC is I like to build as a way to learn about technologies. So when no code was picking up in 2020, I just dove in and made the decision to run our whole fund on no code. So our CRM is Airtable. All of our LP portal, founder portal website runs off of the Airtable, and I have tens of thousands of Zaps running automations in the back end. And then when Web3 picked up, launched an NFT project to learn about it. And then when I found the OpenAI API back in August of 22 last year, just was amazed by what it could do and started building a lot of tools. Initially for myself, our portfolio companies, and today I probably built about 80 tools, about a third of which are kind of running around the back end CRM, helping us run our venture fund. And then in March, I was watching the Hustle GPT movement where people were using ChatGPT as a co-founder. And I was inspired by it and wanted to try it, but I didn't have time. So I asked myself if I could cut the human out of this, Hustle GPT movement, basically developing an autonomous founder. And when I shared a demo of it, a whole bunch of people jumped on and said, this looks like more than a founder. One of my friends nicknamed it Baby AGI, which is where the name came from. I open sourced it a few weeks later. which is around the same time that AutoGPT and a lot of the autonomous agents kind of picked up. This was early in May. It's been pretty interesting. I mean, I was pretty new to open source. I was, surprised to get pull requests, didn't know what to do with it, so I merged two and realized that wasn't for me. I had some community members jump in, and thanks to them, they were able to help kind of integrate some other tools, like Chroma and whatnot. But one thing that was challenging for me is I'm not really a dev by trade, so it was really hard for me to understand other people's code. But I wanted to keep working on BabyAGI. So I took the original BabyAGI code and just started modding it. But because it didn't work with any of the other code, they gave me a little classic folder within the GitHub, and I've started dropping my mods in there. And the mods are named after animals. The theme is Baby Animal AGI. So far I've had Baby Bee AGI, cat, deer, elf, and fox so far. And with each mod, I usually try to introduce 2 or 3 new concepts. Some of the concepts I've introduced include, adding new skills or skills or kind of skills as agents, or skills as mini agents, having a skills template folder so you can easily create skills, and having these skill templates made it easy to have BabyAGI generate its own skills. So one of the things that, today I usually, when I want to build a BabyAGI skill, I usually have it write about 90% of the code. The tasks list it generates to build the new skill is usually looking at a sample skill, looking at the code for that, then doing a documentation search for the API it's going to use, and then it'll take the 2 outputs, feed it into a chat completion to generate the new skill, again, based on the template and kind of the documentation that it searched for. And then there's a skill saver skill, which just takes the code that's outputted and saves it into a skill. So that's been working pretty well. I think a few steps that would make sense to add is kind of, review and tests and whatnot. I think there's huge opportunities in teaching autonomous agents to learn new skills, whether that's by writing code using, something like, Open Interpreter, writing, APIs, kind of like how I described. And there's probably other ways as well, right? Skills can be a chains of functions or chains of API calls as well. And I guess, in Baby Fox, I started adding a user interface that split it into kind of a chat UI separate from the output UI, which I thought was felt much faster than ChatGPT, where you're, asking a question and then needing to have it finish before you ask the next question. So, that's kind of again, it was kind of an abbreviated history, but I've talked about this and I've tweeted about this also much, so I wanted to kind of quickly get through it and then just chat about, autonomous agents and opportunities. With, BabyAGI, I use it a lot, but that's because as a builder myself, I know what its weaknesses are. So it's easy for me to use something that fails 20% of the time because I just manually do the other 20% of the time. But if you want to sell this as a product, working 80% of the time usually isn't good enough. You're going to have pretty high churn. Most users are not going to want to pay for something that fails 20% of the time. And I think that's where we're seeing largely put autonomous agents go in one of 2 directions. One is the vertically focused one. When you vertically focus an autonomous agent, the number of integrations you need to build can be, focused. The type of core actions can be predicted, so you can make you can make sure that it can do some of the core actions that's required for that specific kind of vertical or use case. And so a lot of the autonomous agents that I'm seeing now on the market that have revenue and users tend to have a more vertical focused approach. That being said, I do think there's still a lot of opportunities for general approaches, which I would say is the other one. You can definitely build just a general SaaS tool, but candidly, I just don't think the market's there, again, with the challenges of it just not working enough. With the general approach, what I've seen, and this is a little hard to build in a hackathon, is almost more of a consulting. I call it, it's almost like the Palantir approach, where they're building a core framework for autonomous agents that could do anything, but can't do anything immediately. And then what they're doing is they're taking this framework and going into large enterprises and saying, would you like your own custom, autonomous AI tool? we have a framework that will plug into all of your tools, and we'll set up all of the actions and the regular use cases, so that anything you as a company would expect, we as developers will make sure that our framework is adapted to. And I think that's a pretty interesting approach, because that allows you to, one, get paid, and two, you can actually spend time building it into that company, so you can actually make it work for them, because it does take a little tuning for a company. I think, especially if you're going for a more general approach where it works with a lot of different tools and a lot of different work. So those are the two high-level approaches. I think there's a lot of kind of fuzzy in-betweens as well. And I think on the fuzzy in-between, I'd say some of the stuff that's tackling almost, I feel like, calendars, emails, that kind of stuff, I feel, I guess any of the approaches can generalize over time, but I think stuff working on kind of core workflow like email and calendar can probably generalize easier into other functions. I'm going to pause for a quick second. If anybody has any questions, thoughts, or again, if there's anything people specifically want to hear about, please just drop it in the Twitch chat. I think a couple areas that I'm excited about exploring now, that's top of mind for me, that I haven't seen too much of, but I've heard a lot of people talk about is using knowledge graphs. Again, I'm relatively new to it. I started exploring it maybe 2-3 weeks ago. If you follow me on Twitter, you might have seen me drop a tool called Instagraph. I think that was about 2-3 weeks ago. That was me just like starting to learn about knowledge graphs. But it's a tool where you can drop in a text description or a URL, and it will output an interactive knowledge graph. For those of you who don't know, right, knowledge graphs are kind of the node and edge type of graphs, where it's the data is described as relational, where you have nodes, which are objects almost, and edges, which describe the relationships. What I didn't realize, and again, for those of you who know knowledge graphs, it's going to sound super obvious, but I'm going to speak as though some people don't, because I didn't. What's cool about knowledge graphs is that you can calculate things like distance, right, between them. And depending on the types of edges, you can actually give them weights. So you can actually start doing calculations on relationship between multiple entities. And I think that, even though I don't fully understand it, like abstract-wise, I understand that like in a knowledge graph, there's more insights that you can gain, perhaps, or calculate more easier than if it was in a tabular format. And I think this, I imagine with with something like an auto agent, using a knowledge graph as a kind of memory would be fascinating. The most obvious use case for me that, when someone said use it as memory, was actually just taking all of the outputs of the auto agents as it's thinking through, and then running it through something like Instagraph. So as it outputs something, whether it's after a web search or chat completion, it would then turn that knowledge of like objects and relationships into a knowledge graph. And then if we just kept throwing all the knowledge graph it generates into one large knowledge graph, and we do some fuzzy matching of nodes, maybe using some vector embeddings to match nodes and using an LLM to confirm whether or not they're the same, we can eventually, in theory at least, it makes sense that you could build a large knowledge graph that captures all of an auto agent's memory, which could allow you to ask it questions and retrieve knowledge in a different way than I store it now, which is just like big paragraph formats. The reason this is exciting for me is, well, I guess specifically for this memory, is probably around the idea of retrieval from knowledge graphs, right? Llama Index, I think, already has a tutorial on it somewhere. But the idea is that instead of vector searching for, let's say, a sentence and grabbing the sentence above and below, which is the traditional kind of RAG retrieval methodology for giving AI memory, what if we vector searched for nodes and grabbed all the nodes close to it? It seems to me that it would be, if you can set up the graph right, you can actually get a better comprehensive understanding of perhaps that node if you're grabbing kind of relevant nodes to it and snagging all their relationships. Taking it one level higher, again, these are like more experiments. I'm just talking out loud because you guys are building, and maybe you'll be inspired to like incorporate some of this into some of the stuff you're building. But maybe every objective that I run, every skill should probably be a node as well. And then every task should be a skill as well. So I'm now imagining, right? So you have, let's say you run 10 objectives. All of those should be nodes. They should be connected to task list, which has multiple tasks. and each task is connected to a skill. But then when you do that, you can easily start mapping, what other tasks has that skill been used for, what other objectives are most similar to it. So I can imagine doing some sort of math that includes both knowledge graphs. So you could say, for each skill, look for for each task, go to the skill, look at all the tasks, find all the objectives, and then do like a vector search. So you find the most similar objectives that use that same task, the skill for the task. And there's probably some sort of optimization you can do there. It's pretty theoretical for me at this point, but I think that would be pretty interesting. And then also, it would just allow you to capture all of the historical runs that it's done, and then as different users use it, kind of being able to compare across different objectives and tasks and skills. So that's I think something pretty interesting to explore around knowledge graphs that I haven't people do too much. What else? What else was I going to talk about? Oh, I think I was going to talk about what to build with autonomous agents. Again, this is, I know I'm rambling a little bit, but you guys are building this, so I hopefully you're following all the different parts. But I'll quickly step back and talk about a tool I use often, which is actually what I might call like a semi-autonomous, or it is autonomous, but it's one of those handcrafted autonomous agents. But at Untapped, we have an investment memo tool, or an AI analyst is more what I call it, where if I give it a URL, it will go and scrape the website, take this scraped website content, send it to OpenAI to write a summary of what they do. But then I'll send that back to OpenAI and do further reasoning, like understanding who the customer is, their pain point, risks, business model, whatnot, and ask a whole bunch of questions. And those all get outputted. And then on top of that, I also ping a couple APIs like Built With and Product Hunt to get the tech stack and sentiment analysis of reviews. I also have a couple of tables I do a vector search against. So I get the 5 most similar startups that's in our CRM that we've looked at, 5 most relevant VC-backed acquisitions, as well as the 5 most relevant unicorns to that company. And what's powerful, right, is that like this autonomous agent, to some degree, if I click a bookmarking tool on my phone or my computer, I get all that info at once. I call it a handcrafted autonomous agent because I wrote every single prompt and it's chained. And I mean, these existed prior to kind of the BabyAGI AutoGPT craze, but it's very practical because it's something I do, I do all the time for every company. I guess one of the points I'm trying to make here is that the most valuable automation processes for companies today are the ones that are repeated the most. But for the ones that are repeated the most, you actually don't need the LLM to generate the full task list and reason. If you actually try to get BabyAGI or AutoGPT to to generate, to do what I did with the deal memo, there's a lot of inefficiencies because like if I know exactly the kind of prompts I want to use, it doesn't make sense to ask the LLM to generate it. Or at least so I thought initially. But it's worth thinking about as you're building these auto agents. And I think where auto agents are extremely powerful is in the edge cases, right? In the kind of tasks or objectives that you don't do often, but maybe it's close enough to something you've done before, so it's able to reason and figure out how to do something that you don't repeat all the time. One of the things that worked for me, because I'm trying to kind of consolidate and eventually take all of the tools I use outside of BabyAGI and get BabyAGI to do all of them. One technique that worked really well for me was giving it using the task list examples to guide future task lists. I guess I should pause here. So anybody who's not familiar with the biggest difference between kind of BabyAGI and AutoGPT, and correct me if any, I mean, some of the stuff might be updated, but AutoGPT is more similar to kind of the React agent or LangChain, where you would where it would after it would do something, it would just reflect on it and then figure out what to do next. BabyAGI, the biggest difference was it was kind of the first instance of generating a task list ahead of time and then just looping through the task list. And then, of course you can update it, but it had an ongoing task list that went further than one task ahead of you. So the reason I brought that up is, so today, at least in the more recent BabyAGI mods. I think this was introduced in Baby Fox AGI is where it was introduced, is if every time I run an objective, right, it generates a task list, it runs through the task list, and there's an output. I feed the objective, task list, and final output into a reflection agent to think about, to write a little note about how it went. Like, oh, this was the objective, we did a good job, or, we should have done this search as well. And then I store all those. Whenever I run an objective, I then do a vector search against all of the past stored objectives and then pull those in, and I use them a couple of ways. I use the reflection from the most recent, most relevant objectives to write a little reflection note for the task creation agent. So for example, if I run an objective about searching for me, let's say I'm a VC, and then after the output, the reflection says, you know what, we should have done a search for his portfolio companies. Maybe that would have given us a better picture of who he is as an investor. If that note is then fed into the task creation agent, that task creation agent actually is more likely to generate, add that task into it. And not only that, it has the previous task list as well. So it has both the past objective, task list, and reflection note that it can use to generate better task lists. So with that kind of function, I'm able to, one, guide task creation. I can actually create example task lists for a certain objective and just store it in there if I wanted to pull that task list as an example. Or there's some sort of self-reflection built in to some extent. So if I run the same objective multiple times and it doesn't do it well the first time, it does get better because it'll use its reflection notes to create a better task list the next time. Which was that was Baby Fox, and I think the big revelation for me, I think I called that reflection the Foxy method. The big reflection for me was that when I before adding that type of reflection method, I was trying to figure out how to guide it during the run. But one thing that I realized about myself is that if I ask, an employee to do something for me, I'm never sitting over their shoulder. They basically do the work, they come back, and then if I want them to do it better next time, I just give them the feedback, and then they work on it. They do it better the next time. And I think, I want to work with my autonomous agents the same way as I want to work with people to some extent. So a lot of the way in which I'm designing BabyAGI and I'm thinking about designing BabyAGI is, how can I get it to work more like a person I like to work with? And that's been a fun kind of chain of thought to follow, and a lot of where my inspiration comes from. Thanks for everyone who joined. I know I was a little bit late. I know this was a little bit rambly, but at the same time, I hope that I wanted to just cover a whole bunch of different thoughts that might be relevant to people who are building out autonomous agents right now. I'm really excited to see what comes out of this hackathon. I will be following and tracking the outputs. I'm excited to see the demos and announcements, and good luck, everybody. Cool, I have a minute, I guess. Any questions, thoughts? Awesome. Well, thank you very much for joining me.